So let's find some more derivatives to exponential functions with e to the x as the base. All right, well, the first one, that you couldn't find an easier problem. All right, so when you have a coefficient in front of a function, it's just going to be that coefficient, that constant multiple, times the derivative, constant multiple rule. Well, the derivative of e to the x is e to the x, so the derivative of 3e to the x, come on, it'll probably take longer for my pen to start writing than it would be to solve this one. Here we go. dy dx is equal to 3e to the x, and there we go. That one was pretty easy. Let's see if I can get rid of that stupid box. There we go. Now let's do the next one. The next one is a quotient rule. All right, just a reminder for the quotient rule, the derivative all right, so if u is the numerator and v is the denominator, it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. All right, so here u is e to the x. The derivative of e to the x is e to the x. Right? He is its own derivative. V is x cubed. Derivative of x cubed is 3x squared. That's just the power rule. All right, so I'll give myself a little bit of space here. Dy dx, and most of these, by the way, are in your notes. So just follow along with the note template I gave you, for the last podcast, and you'll be fine here. So dy dx, look at that equal sign, is equal to the denominator, there we go, which is x cubed, times the derivative of the numerator, which is e to the x, minus the numerator, which is e to the x, times the denominator, which is 3x squared, all divided by x cubed. Let's factor out our common factor there. Right, so, and then we'll put any coefficients in front of e to the x. Any coefficients, any x's, etc. All right, so dy dx is equal to, all right, so both x cubed e to the x and e dx times 3x squared are divisible by x squared. So let's factor that out. Right? So we're going to factor out the x squared, and then we're going to have in parentheses x e to the x minus, and let's put the 3 first, 3e to the x, all divided by x cubed. Well, you could reduce that and only have an x in the denominator here. So our derivative is going to be x times e to the x minus 3e to the x. What happened to the other? We got part of an x there. All divided by x. And there we are. There we're done. All right, so that wasn't too bad. All right, and let's continue on. So really, derivatives with e to the x aren't too complicated. So now we're going to add a little twist to e to the x. If f of x is a differentiable function, in other words, the exponent on e is not just an x, but it's more, we're going to have a chain rule. Right? So it's going to be, so the derivative of e to the f of x is going to be equal to e to the f of x, but then we have to take the derivative of that exponent. We have to take the derivative of f of x, and that would be f prime of x. All right, so a new rule for us. The derivative of e to the f of x is going to be e to the f of x, exact copy again, times f prime of x, times the derivative of that denominator. In other words, the derivative of e to the f of x is an exact copy of e to the f of x times the derivative of f of x. All right, so now, why do we all of a sudden have to multiply by the derivative of our exponent. Well, I mean, technically, we could have been multiplying by the derivative of our exponent the whole time. However, it wasn't going to make much of a difference. So if we have f of x, the derivative of that is 1. Right? So if we multiply, if we have y equals e to the x, and we take the derivative, and we use the chain rule here, we'd have e to the x times the derivative of x, which is just 1, so that's just e to the x. Right? So there was no purpose in multiplying by the derivative of our exponent when it's just x, because the derivative of x is just 1. But if we have anything other than just x, its derivative is not going to be 1, and we're going to have to take the derivative of that as well. All right, so let's take a look at a few where we have a chain rule. All right, so differentiation of exponential functions, chain rule for exponential functions. If, just a little reminder here, if f of x is a differentiable function, then the derivative of e to the f of x is e to the f of x times f prime of x. All right. I think like 1 or 2 I already have done for us. So here we have f of x equal, we want to find the derivative of f of x equals e to the 3x. The derivative is going to be e to the 3x times 3, right? Because, I have it down here, the derivative of 3x is 3, right? So it's not just an x, right? So we're going to have that exact copy of the exponential function as part of our derivative times the derivative of the exponent, right? So it's going to be f prime of x is going to be 3e to the 3x. That one wasn't too difficult. Here we have another one, right? So f of x is equal to e to the 2x squared plus 1. If we want to find that derivative, we're going to have an exact copy times the derivative of the exponent. Right? So the derivative of 2x squared plus 1, right? We the power rule, right? So you multiply 2, the exponent, times 2, that would give you 4, and then reduce the exponent on the x by 1, and then the derivative of the constant 1 there is just 0, so we don't really need it. Right? So we're going to multiply e to the 2x squared plus 1 by 4x, and don't leave it like that, right? That's visually confusing, right? Just put it in front, right? So, our f prime of x is 4x e to the 2x squared plus 1. See how much nicer that looks? And then you don't even need the parentheses anymore. I think that's the last one where it's completed for us. All right, so here we want to find the derivative of f of x equals e to the 3x, the 3 plus 5x, right? So we have to have the derivative is going to be an exact copy, which would be e to the 3 plus 5x times the derivative of our exponent of 3 plus 5x. Right, so the derivative of 3 plus 5x, let me just write down the rest of it. So our derivative is going to be e to the 3 plus 5x. The derivative of 3 plus 5x is just 5, right, because the derivative of 3 is 0. Move the 5 in front. So the derivative of e to the 3 plus 5x is going to be 5e to the 3 plus 5x. And there we are. We're done. Look how fast these are going by. 9 minutes, and I've already done like 6 of them. All right, so we want to find the derivative of f of x equals e to the square root of 5x. All right, so that's going to be an exact copy. All right, and actually I'm going to, I'll leave it just the way it is. All right, but when we go to take the derivative of that exponent, we're going to rewrite that as a rational exponent. So we're going to have f prime of x is going to be e to the square root of 5x times the derivative of 5x to the 1/2 power. Right? So that would be equal to e to the square root of 5x times, all right, so we have the derivative of 5x to the 1/2. All right, this is a chain rule. All right, so we're going to have the derivative is going to be 1/2 blop, right, to the, now we're going to subtract by 1, so 1/2 minus 1 is going to be negative 1/2, times the derivative of the inside part, right? So that would be the derivative of the 5x, right? So this one is a chain rule. All right, so now let's clean that up and fill in our blop. F prime of x is going to be equal to e to the square root of 5x times, and I'll put parentheses here, times 1/2, and our blop was 5x, come on, to the negative 1/2 power, and the derivative of 5x, that's 5. Let's clean this up. It's all being multiplied. All right, let's simplify that. Let's get things where they belong. Oh, one little boo-boo here. One tiny little boo-boo. The one tiny little boo-boo is where I wrote the exponent. This parentheses, the 5x, is raised to the negative 1/2 power. This parentheses is for the multiplication. All right, so we have f prime of x equals, move that 5 in front. Come on. So we have 5 times e to the square root of 5x. And then the 2 belongs in the denominator, because that's 1/2. And so does the square root of 5x, because that has a negative exponent. And I changed it back to square root. So here, that is our final derivative, all right? All our steps there. All right, so 5e to the square root of 5x divided by 2 times the square root of 5x. And that's all because we have a chain rule here. So this one was a little bit trickier, just a little bit, just a little bit. All right, so we're going to differentiate each of the following with respect to x. All sorts of colors to make it easier. All right, so here we're going to have an exact copy. dy dx equals e to the 8x, plus we need to take the derivative of the 8x. Derivative of 8x, that's just 8. All right, so our derivative is going to be e to the 8x times 8. Move the 8 in front. So the derivative dy dx is 8e to the 8x. And 1 is done. Let's go to the next one. All right, so we have our derivative is going to be dy dx is going to be an exact copy, e to the negative x squared plus 4x minus 7, hello, 4x, there we go, minus 7, times the derivative of negative x squared plus 4x minus 7. And I'm encroaching a little bit on the next problem space. Let me see if I can move this over just a little bit, since I know I don't need the space over on the left there. All right, so what happened to my minus 7? There we go. All right, so now we have our derivative is equal to e to the negative x squared plus 4x minus 7. What a horrible 7, there we go. And the derivative of negative x squared plus 4x minus 7 is just power rule. 2 moves in front, so that's going to be negative 2x. And that would be now to the first power. And the derivative of 4x is just 4. Right? Let's move that all in front. We are going to need the parentheses here. So our derivative, dy dx, is equal to, and you can distribute or just leave it the way it is. And I'm just going to leave it the way it is. Negative 2x plus 4 in parentheses, otherwise it's going to be wrong, e to the negative x squared plus 4x minus 7 power. And there we go. Last but not least, right, we have y equals e to the x squared minus 3. The derivative, if I can squeeze it in, dy dx is going to be the exact copy, e to the square root of x squared minus 3 times the derivative, and I'm going to rewrite this now as a rational exponent, x squared minus 3 to the 1/2 power. Right? So that's going to be dy dx is equal to our exact copy, e to the x squared minus 3 times, all right, so now we've got a chain rule. All right, so we're going to have the derivative of that's going to be 1/2 blop. Right, the derivative of blop to the 1/2 is 1/2 blop to the negative 1/2. And then we need the derivative of the blop, which is, let's see if we can squeeze it in, x squared minus 3. So much, I forgot to write in the x squared part. Could use just a wee bit more space. Just a wee bit. Let's see, can we move over? You move over, there we go. Just get up nice and close to that other term there. Yeah, you get nice and close. You move over. You move over. You move over, whoops. I think it's supposed to be an exponent, there we go. And now I can squeeze in the derivative of x squared minus 3. All right, so our derivative dy dx is equal to, let's fill in our block too, e to the x squared minus 3 power times, I'll put parentheses there, 1/2 to 1/2 times x squared minus 3, and that's the negative 1/2 power, times the derivative of x squared minus 3 is just 2x. Derivative of the 3 is minus 3 there is 0. All right, so now we need to clean this up. dy dx equals, all right, in the numerator, I've got e to the x squared minus 3. In the, oh, and we also have an x there, right? Don't forget the 2x, right? We got the x. Yeah, x times e to the x squared minus 3. Why don't we have a 2? Well, 2 times 1/2 is going to be 1. That's going to cancel each other out, right? So this one and this one are just going to cancel each other out. So that's going to leave just, who's left? Just the square root of the x squared minus 3. And everybody else is taken care of. And that's it, right? So hopefully these were okay for you. We're going to do, I think, a few more. I know a few more. Some of them are in this set of notes, and some of them, like this, are in the other set of notes, right? So those notes I gave you, those 9 pages, you're going to stop taking notes in that one and go back to the packet before, right? So it had some problems for you to do and then some problems we did together, and you're going to go to this one, and you'll see this page, rules for differentiation. I think it's page, I don't remember. It's, I have no clue. Maybe 212, 213, 214, 215, something like that. But after the problems that you're supposed to do, so you'll pass by the exponential problems that we're not doing right now, and the log problems you're not doing right now, and then there's another page of problems you're not doing right now, and then you get to the notes. Go to the back part of those notes, the parts that are, I think the notes start on page 210, if I remember correctly, and then look for this page where it says differentiation, rule for natural exponential function, and as a reminder to yourself, put these 2 rules in. Right, so if we take the derivative of e to the x, it's just e to the x. And if we take to the derivative of e to the f of x, right, we don't just have an x, then it's going to be the exact copy, e to the f of x, times the derivative of the exponent, times f prime of x. So write that in, right, into your notes. And now let's go into a few problems. We're only doing the ones where we have e to the x, and when we're stopping, I think we're doing like 6. And we'll fly through these. All right, so we have e to the sine x. All right, that's not an x. So we're going to, our derivative, f prime of x, is going to be the exact copy, e to the sine x, times the derivative of sine x. Well, the derivative of sine x is cosine x. Come on. E to the sine x times cosine x. And this should be in front, all right? That's visually confusing. You might think that the exponent is sine x times cosine x. Kind of looks like that, all right? So we want to move, always want to move whatever coefficient you have, even if it's a trig function, in front of e to the sine x. On this one, I am going to use parentheses. I either need to use them there or around the x, just so it doesn't look like the cosine of the whole thing. Right? And then times e to the sine x. I think that is generally how we write that. Let's move on to the next one. Again, we have a chain rule, but a nice, easy chain rule. That one wasn't too difficult, I hope, for you. All right, so f prime of x is our, come on, as we wait for my handwriting to come up, is going to be an exact copy. Yes, we're waiting. Any day now, Mr. Smartboard. There we go. Exact copy e to the 2x plus 3 times, since that's not waiting, there we go, the derivative of 2x plus 3. And that's pretty easy. So we have e to the 2x plus 3. The derivative of 2x plus 3 is just 2. Right? We have a power rule there. The exponent would decrease by 1, so you'd have x to the 0. So that's just 1, and that's just going to be 2. And the derivative of the 3 is just 0. Right? So the derivative of 2x plus 3 is just, I'm going to do this so you know you're taking the derivative of the whole thing, is just the 2. So all we got to do is clean this up by putting the 2 in front. Right? So 2e to the 2x plus 3. And another one is done. I bet you this won't even be 30 minutes. All right. Again, we have a chain rule. Another nice, easy chain rule. F prime of x is equal to, we do have a constant multiple there, a scalar multiple, a coefficient. All right, so it's going to be an exact copy along with that scalar multiple, right? Because if you have a coefficient, the derivative is just the coefficient times the derivative of whatever let's try that again. Times the derivative of whatever follows. My mouth didn't want to work there. So the derivative of 3e to the 2x is just going to be 3e to the 2x times, since that's just not an x, the derivative of 2x. All right, we're going to take the derivative of 2x. Well, that's pretty easy. You can't get any easier than that. So we have 3e to the 2x times 2. Right? Derivative of 2x is 2. Let's multiply the 2 and the 3 together. Right? They're just both constant multiples now, both coefficients. All right, so that's going to give us 6e to the 2x, and that one's done. And now the last one here. Now we have a product rule. Right? So with a teeny little chain. All right, so u is 2x plus 3. And v is e to the 3x. Derivative of 2x plus 3 is 2. The derivative is going to be e to the 3x times, you got to take the derivative of the 3x. All right, so that's going to be our exact copy, e to the 3x. The derivative of 3x is 3, and let's move the 3 in front. So 3e to the 3x. Right? And so now we can take the derivative. Remember, for the product rule, I'll just put it up here. Our derivative is going to be the first times the derivative of the second plus the second times the derivative of the first. Right? So f prime of x is equal to 2x plus 3. Let's put parentheses around that, because all of that is being multiplied by 3e to the 3x plus the second part, which would be e to the 3x, times the derivative of the first one, which was 2. Let's clean this up a little bit. Let's also pull out a common factor. All right, so common factor we could pull out is e to the 3x. Let's pull that out. So f prime of x is equal to, because looks a little visually much here. E to the 3x, and then we'd be left with 3, that would be left there, times the 2x plus 3. I can't pull that 3 out. And then plus, the only factor left over here is 2. Let's distribute, combine like terms. So f prime of x is equal to e to the 3x times, we have 6x plus 9 plus 2. And so finally, f prime of x equals e to the 3x times 6x, factor out e to the whatevers. All right, and notice how much simpler that is. And later on, when we're needing to set it equal to 0, we'll be all ready to do that. All right, so I'm just a little reminder here to factor out e to the x and simplify. And in this case, it was 3e to the x we could, just e to the x we could factor out. Or actually, in this case, it was e to the 3x. All right, just a little reminder there. I think I've got maybe 3 more problems. I might hit the 30-minute mark on this one. But I think I have 3 more problems. All right, so here again, product rule. All right, so u is equal to, and we won't write it again because you have it. This is all one page for you. I had to divide it up into 2, otherwise I have to write really small. And so we already wrote the product rule on the last page, which is the same page for you. So u here is x squared. The derivative of that is 2x. And then v is going to be e to the 2x. The derivative is going to be the exact copy, e to the 2x, times the derivative of our exponent, which is 2x. Derivative of 2x is just 2. So let's rewrite that as 2e to the 2x. All right, so our derivative, f prime of x, is going to be the first, which is x squared, times the derivative of the second, which is 2e to the 2x, plus the second, which is e to the 2x, times the derivative of the first, which is 2x. This time, we can factor out, so on these ones, little reminder, we can factor out, and we can factor out a 2e to the 2x, right? Because there, it's right there, and it's also right there. All right, so we're going to have f prime of x is equal to, all right, so we've got 2e to the 2x times the x squared and a lowly x. That's all that's left over here, that x right there. All right, and we factored everything else out. This one's done. All right, much visually nicer and easier to work with. All right, so we have f prime of x. Actually, before we do f prime of x, let's rewrite that as an exponent. So we have f of x equals e to the 2x minus 6 to the 1/2 power. Right? So derivative is going to be 1/2 blop to the negative 1/2 power times the derivative of e to the 2x minus 6, which has a chain rule to it. All right, so let's fill in the blop and let's take the derivative of that. So we have f prime of x is equal to 1/2, and that would be e to the 2x minus 6 to the negative 1/2. The derivative of e to the 2x minus 6 is going to be e to the 2x minus 6, I'll put parentheses around it, times the derivative of 2x minus 6. So we have to take the derivative of 2x minus 6. So d dx, by the way, it means take the derivative of 2x minus 6. Well, that's a pretty easy derivative because it's 2. So f prime of x is equal to 1/2 times e to the 2x minus 6 to the negative 1/2 times e to the 2x minus 6 times 2. So the 2 and the 1/2 here, not right in red, they're going to cancel themselves out. That would just be 1. All right, so that's gone. All right, so now let's see what's left here. Let's simplify. This here should go to the denominator. Right, that goes to the denominator. And this is going to be in the numerator. Right, you just got things multiplied by one another. Right, so let's simplify that negative exponent. F prime of x is equal to, we have e to the 2x minus 6, and I'm not going to simplify it yet. I'm going to leave it with the exponent and not a square root. E to the 2x minus 6 to the 1/2 power. Hey, we have 2 of them. We have the same thing. This is e to the 2x minus 6 to the first, and that's to the 1/2. Couldn't we simplify that? Why, yes, we could. Right? So if you have like bases raised to a power, you subtract the exponents. So this is just going to be e to the 2x minus 6 to the 1 minus 1/2 power. Well, 1 minus 1/2, that's a half. So guess what? F prime of x is equal to, whoa, square root of e to the 2x minus 6. How about that? We got the same thing again. Pretty interesting, huh? Doesn't happen very often, does it? No. If we hadn't had just that function there, we would have canceled everything out. And now we have e to the 2x, square root of e to the 2x minus 6. It's its own derivative. How about that? All right, so let's continue on with the last problem. And that's this one here, and we have a quotient rule. All right, so it's a reminder on the quotient rule that our derivative is going to be, so u is the numerator, abbreviate, and v is the denominator. All right, so it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. All right, so I've got a lot more space than you probably have, so I'll try not to write too much here. U is equal to e to the 5x. Derivative of that is going to be e to the 5x times, we got to take the derivative of the 5x, and that's just 5. All right, so du is going to be 5e to the 5x. All right. Denominator v is 3x squared. Derivative of that is 6x. Just 3 times 2, reduce the exponent by 1. All right, so our derivative, I'll put it over here, f prime of x, hopefully I have enough space, is equal to the derivative of the denominator, which is 3x squared times the derivative of the numerator, which is 5e to the 5x, minus the numerator, which is e to the 5x, times the derivative of the denominator, which is 6x. I'm going to write the 6x first. 6x, and then e to the 5x. All right, all divided by denominator squared. So 3x squared squared. All right, let's simplify this. Let's factor out we can factor out an x and an e to the 5x. All right, it's a wise decision. I get in the habit of factoring out these e to the x's. All right, we have x e to the 5x. All right, so for the first term, we're left with a 3. And actually, let's multiply that. We're left with a 3 times 5. The two coefficients could be multiplied. So we're left with a 15. And then we have an x. And we have, that's it. And because e to the 5x has been taken out. All right, so we have 15x. And then minus, all right, so we're going to be left with a 6. Because the x has already been taken out. Minus 6. All divided by, come on, and then my fraction bar. All right, 3x squared is going to be 9x to the 4th. And now we can reduce. And we should reduce. We should cancel out one of those x's as soon as it finishes writing. There we go. We got half an x. I don't know why it hit that. 4. How about the rest of my x? I give up on it. I'll write it in myself. 9x to the 4th. All right, so now where's my, I just picked up the other pen so I can reduce. Come on, where's my exponent? Oh, now it's in red, look at that. I was picking up a red pen. So we can reduce that to x cubed. And this one is gone. So our final derivative, f prime of x is equal to, come on, e to the 5x times 15x minus 6. You could factor out this 3 if you wanted to. Doesn't make that much of a difference if it's 5x minus, if there's a 3, e to the 5x times 5x minus 2, or if the 3 is just distributed, so don't worry about that. Divided by x cubed. And there we go. There's our final answer. And that, I believe, is my final problem. Because I think the rest is a new lesson. Yep. All right, thanks for watching, and bye for now.